Now, before we go to the example and how to use the Excel to solve the example that we have done manually last time in the class, okay? So we are going to look at what are the things that appear in your Excel document, okay? So that you can benefit from the things that are available in the Excel document, okay? Are you all okay with my voice? Everything, class?
Yes, sir.
Okay. Now, let us begin with the content. Okay, these are among the things that we should cover under chapter 3. Okay, under chapter 3, there will be basically 8 of them, but we have already covered until number 7. Okay, that include the Excel function, the learning outcome for the Excel sheet, terminologies and concept. And then the fifth is the exploration on the confidence interval and hypothesis testing, that will be on the concept. And number 6 is the estimation and hypothesis testing for single population, which include the mean and proportion. And the second one is for the two population that involve the mean and proportion. On Monday, we are going to see on how we can do or perform the hypothesis testing for two population median. And for number 8 now, this one is specifically for data that are not normally distributed. So that's why we have number 8. Okay, so that will be under content for the Excel document. Okay, now for the Excel function, okay, for the Excel function, please be careful on the content, because the Excel can be further explored throughout the window to your right. Okay, so please look at every single content that are available in every sheet given to you. Okay, for the Excel function, okay, the Excel function is divided into several category. The first category is for the confidence interval for single mean. Okay, CI for single mean, and we have to calculate the margin of error, or E. Okay, the margin of error, last time we have discussed about CI. We know that we can have the point, but from the point, in order to have the confidence interval, we extend the point into an interval. So from the point, the middle point to the left and to the right is what we call the margin of error, or E. Last time we discussed on how to find the sample size using the margin of error. Okay, so that margin of error is the one that we have discussed. So it's not a new thing for you. Now, how to get the margin of error? We know that we can have the Z distribution, or the normal distribution, and the T distribution. So you have two category here. The blue one is for the Z distribution, and the green one is for the T distribution. When do we use T distribution, class? When do we use T distribution, class?
when n is less than 30.
Yes, when n is less than 30, we have to use the T distribution. But what if sigma is known and n is, for example, 20? Which distribution should we use, Z or T? I repeat again, n is 20, and your sigma, the population standard deviation, is given to you. Shall we use the Z or T distribution?
Z distribution.
Wrong. T distribution. Whenever you are given the sigma, go back again to your notes. Okay, to your notes. Which one is for the first? This one. Can you see it? Much clearer, right? When sigma is known, okay? When sigma is known, sigma is unknown and is greater than 30. There are times where we have sigma is unknown and sigma is unknown. Sorry, sigma is unknown, sigma is known, but your n is less than 30. then you have to use your Z distribution. If I'm not mistaken, it's under the two population. So you have to be very careful. So for this case, if sigma is unknown and n is greater than 30, we still use Z. See clearly here, we use Z. Okay. And when n is less than 30 and sigma is unknown, definitely we have to use T. So there are a condition where sigma is known or unknown, you still have to use the Z distribution. So this thing can be checked from the list of formula that I have given to you in the last class. So please make sure that this particular mistake is not being done during your assessment, especially. Okay. So be careful when to use T and when to use Z distribution. Now, I have put some example here. Okay, it will be much easier if, let's say, I'll just go straight to the point where we find in example 3.1. If you look at your textbook on page 93. Okay, on page 93. Okay, so these are the things that we can do in order to get the CI for example 3.1. Okay, now before we go to the example 3.1, let us look how we can find the Z distribution or the margin of error. Where is the margin of error, class? The margin of error is where you have your, sorry, my pen is a bit crazy tonight. It's like it's kind of become a laser. So let's say if we are talking about the mean, this is the X bar. Once we have our margin of error where we at this particular side, we are going to plus, let's say we are using the Z distribution. So you will have Z alpha over 2 and square root of sigma or S over N squared. Okay, so that will be, there is no square root. Sorry. Um, okay, so that will be multiply. Okay, so this is what we call as margin of error E. And this E can be calculated later. How we can calculate them? Let us see. Now, since we are talking about the left and the right, so we are going to have the margin of error at the left side and the right side. So how we calculate the margin of error? So this is the margin of error. My cursor here now is giving you the margin of error. How we calculate that? Using this particular formula. So we are going to find confidence dot norms, and what are the things should be included in your bracket are all the information given in your questions. For this particular simple example, before we go to example 3.1, let's say we have alpha 0.05 and the standard deviation is 2 and the sample size is 30. So these are all the information need to be put into your equation or Excel function. So I9 is for the alpha. Okay. I10 is for the standard deviation and I11 for the sample size. Okay, so let me do it again here. So you can try on your computer as well. So I have equal to confidence norms just now, right? Confident dot norms. So double click confident dot norms. Okay, and then here you have the instruction alpha, standard deviation, and size. So just go to the cell where the alpha is stored and then put comma, and then go to the cell where the standard deviation and then put comma, and then go to the cell, click to the cell where the sample size is there, and then put the close bracket and then enter. Can you try, class? Just copy, do it using the same information. Everyone try, eh? Those who have any problem, let me know.
Madam,
Yes.
dia kalau yang saya tekan tu jadi hashtag 6 tu siapa? Hashtag NUM.
Oh, null. I think okay, if you one another way to do it is you can use just input the value automatically. For example, click equal to, and then go to confident, double click, and then you know the alpha, just put 0.05. Can you try that way? Maybe it could be helpful. And then you put the standard deviation is 2, and then the sample size is 30, and then enter. It should give the same exact answer.
Okay, dapat. Okay,
Okay.
okay.
So you have if you are not familiar on how to move your cell, choose them using the cursor and everything, you just straight away put the value inside the Excel function. Okay, so that will be for Z distribution. What about for T distribution? So for T distribution, almost similar, but then the instruction will not use the norms, but instead it will use the T, confident.t. So let's say we go to empty cell, put equal to, and then confidence T dot T, not underscore T, T. And then if you wish to use the same exact method, put the key in the value, and then the standard deviation is 2 and the sample size is 15. And then close the bracket and then enter. So you will get your margin of error using T distribution. Now class, remember, when you are using the confident equal the function confidence.norms or confidence.t, you are calculating the margin of error that have two tail. I mean, it will be divided into two, but that particular divided into two is not portrayed in the Excel function. So you have to know. Just directly use all the information given and then put in your Excel. Now, why don't you repeat again example 3.1? What I did was I just copy this particular cell and then paste under example 3.1. So in this case, let's say you just repeat at this side. Okay, so if you look at example 3.1, so go back again to your example 3.1 and study what are the information given. Okay, so if you look again, you have example 3.1 says that you have n equal to 20. Okay, standard deviation is equal to 15, but the standard deviation is for sigma. That's why I put sigma here, so that I am sure that which formula that I wish to use. So when sigma is known, automatically you are going to use the Z distribution. That's why you have to take note all the information given to you. Okay, so in this case, we have alpha 0.05, and then we have standard deviation 15, and then we have sample size 20. Okay, so calculate the margin of error. Can you repeat again somewhere and in the empty cell before we can calculate the CI? Okay, if I were to use to do again, then I use confident, norm, and then I have my alpha, and then I have my standard deviation and sample size. Enter. Okay, up until now, is everyone understand what should you do in order to get the margin of error? Okay, class? Now,
Okay.
okay, now how can we find the CI? Last time we do it manually, right? Okay, now since we have know that what is our margin of error, Now we know that by using the given mean sample mean, we can find the lower bound and the upper bound. So what did I do is that I just copy what is my x bar because I'm dealing with the mean sample. Then what should I do? I calculate the CI lower and CI upper. How? CI lower, I use equal to, I know that I have to deduct the mean with the margin of error. So I choose the cell for the X bar minus the margin of error. And then enter. I got the lower bound, which is exactly the same as what you got in your textbook. Now repeat for your upper CI. So upper CI should be plus. So I have 64 the X bar plus margin of error, enter. So I have 70.87, exactly the same as what we have in our example in textbook. Okay? Okay. Is there any question, class? I go straight away to the calculation. Yeah. So it's actually okay. I don't want to put a headache to you. So I'll just go to this Excel function. Are you all okay? If you are all okay, why don't you try use example. The one that we haven't done is exercise 3.2. Exercise 3.2. So let's say I erase everything. Now I just copy and then paste. Do it for exercise 3.2. I change exercise 3.2. 3.2, exercise 3.2. Is it 3.2? No, sorry, there is an exercise 3.1. Sorry, I skip. There is another example 3.2. Let's say we do example 3.2 first, class. Sorry, I skip one page. Example 3.2. We put all the information that you have in 3.2. So I have a treatment at emergency room. Now a random sample of 30, so change into 30. And then standard deviation, the mean is 174.3. 174.3. And then the standard deviation of the sample is 40.3. 40.3. Now sigma is unknown. Unknown sigma. Okay, unknown sigma. But since n is equal to 30, so we are going to use our Z distribution. So we don't have to change our calculation. So what you got here automatically calculated for you. Did you get that on your Excel, class?
Dapat, madam.
Okay, so now we calculate. See, everything, once you have changed the keyword, the calculation is being done for you. So X bar plus minus the margin of error, you got 159, but there are something wrong with the alpha is 0. Now what is wrong with my calculation, class? The alpha, right? The alpha, right? The alpha is 99, right? 99 is 0.01, right? Okay, so 0.01. See, once you have changed into correct one, so Excel is very easy, but then you have to be very careful in terms of all the information that you need to use are all correct. So once I have corrected my alpha, all my calculation are correct then. So if you look at your textbook on page 94, the lower CI is 155.35 and the upper CI is 193.25. Okay? Easy, right? Okay, now why don't you try exercise 3.1. Exercise 3.1, number 2 Roman. Number 2 Roman. Let's say I copy again. Control C. Control V. And then we are doing exercise 3.1. Okay. Now put all the information. We have a random sample of 35. And then standard deviation. Look very carefully. We found that the mean waiting time is 22 minutes. So waiting time is 22 with a standard deviation of 8, which from the sample. So standard deviation of 8. Okay, unknown sigma. And then what else? For 2 Roman, calculate the margin of error for 90%. So 0.1. Right. Okay. So automatically, by using the given formula, you know that for 90%, you will get this. 19 until 24. So how can you conclude about the CI? So remember, you have to conclude the CI because the conclusion of your CI will give you 1 mark. So don't miss that. Okay? So how can you conclude about this class? How can you conclude? What? We are 90% confident that the that the mean waiting time for all the individual is between waiting time for the service. Waiting time for all. We are 90% confident that the mean waiting time for all the individual mean waiting time. I would like to write this way: mean waiting time for service in by a bank. By a bank mean waiting time for service by a bank for all the individuals is between, right on your own class, because I'm doing at my Excel sheet, is between 19.78 minutes. Okay. And 24.22 minutes. So that will be your conclusion for your confidence interval. So you can repeat again for your 90%, okay, margin of error. Yeah. Okay, so that will do for your exercise 3.1. Now, what about the proportion? Okay, let's do for the proportion. I think I have done something in at the proportion. But the example in your Excel sheet is referring to the data that we have done. Yeah, I did also at your, but never mind. I'll just do at the sheet over here. Okay, what about the proportion? Okay, now for the proportion, let me check. Is there any other things that should be noted? I haven't done for the proportion. Okay. Okay, now let us just use the Excel function just now and do for the proportion now. Almost similar to your proportion. Okay, it's just that you need to know how to calculate your p hat. Okay, for example, let's say we do example, just copy, Control C, and then we do for proportion, Control V, proportion. Are you all okay, class?
Okay, madam.
Okay, so let's try for proportion and we do example 3.3. Now, apart for the proportion, we have to identify what will be our p hat and everything. So we have to identify what will be the sample size and the x. For example, 3.3, you have sample of 1,500. N is 1,500. 1500. And your x, not x bar, x. X is equal to 600 of the student agreed. So 600. So you will have your, let's say I move upward. You have your p hat here. P hat, it should be 600 divided by 1,500. Okay, you can do that way, or you can just equal to 600 divide by 1,500. Either way can do. Okay, so which one is easier to you, then it will be okay. Okay, so that will be for, I think it would be helpful if I put okay, so it would be much clearer. So for proportion, okay, for proportion, we don't need to have the standard deviation, right? Since we are, okay, now what happened is that, okay, let's say in order to find the Z, you still using the same formula. It's just that you need to find now the Z. Okay, hold on. The Z distribution. Okay. Find the Z test. Z alpha. Total. Okay. Okay, now for the proportion, let me check for the proportion what is being For proportion, critical value. Now, okay. It's going to use the T inverse 2T. That will be for Z. Norm inverse. So Z distribution. Okay, Z distribution. Now, for the proportion, we are not going to use the confident dot norms, because confident dot norms will have to use the input will require these three: the alpha value, the standard deviation, and the sample size. But since for the proportion, we don't have the standard deviation, we only rely on the value of alpha as well as the critical value or the Z. Okay, since we are dealing with Z, okay, for proportion always the Z distribution, so we are going to use this particular this one, yeah, norm. Let me check. It's almost the same. T distribution. Yeah, this one. Okay, this one, the third column, not the middle column, the third column, to find the margin of error, or not the margin of error, the Z alpha over 2 value. Okay, so this is the formula. Okay, norm dot S dot inverse 1 minus AJ. So what you should have is that you should have your probability value or alpha value. So in the case of, let's say I choose here, let's say norm dot inverse just now equal to norm dot S dot inverse. Double click here. So it requires the probability. That's why in the first place, when we are dealing with CI for mean, we are using the alpha. Yeah.
Kita buat soalan mana satu ni?
Which one? What was that?
Kita buat soalan yang mana satu?
We are using example 3.3 proportion. Proportion, page 95. Okay. So I want to show you how to find the Z alpha over 2. Because we are using Z alpha over 2 to find the margin of error. So this will be the function. I am trying to explain to you the way we find the Z alpha over 2 is a bit different from the CI for mean. Because CI for mean, we use the three value: alpha, standard deviation, and the sample size. But for proportion, we need to use this. Okay, so norm, S, inverse, and probability. So in your case here, okay, so go to the third column to find the Z, the critical value. So example 3.3 just now for the proportion. This one is on page 95. Page 95. Okay, so now class, we have got our p hat, we know our alpha, and let's say we bring this the sample size over here, because the sample size is already there, so just delete. Okay, now what would be your Z alpha? Now in this case, it is no longer Z alpha. Okay, so I will change everything. So it will be Z alpha over 2. Let me insert just to
Madam,
yeah.
dia punya alpha 0.01 ke 0.05?
In this case is 0.05. Okay,
Okay.
I haven't correct that, yeah. So alpha over 2, so this will be my alpha over 2 value. So my alpha is 0.05. Now, so you should have for proportion the n, the x, the p hat, and the alpha. That's are all the input information before you can calculate using Excel. Once you have all this, okay, begin finding the z alpha over 2. So we know that we are using the norm inverse just now. Go to the third column, norm.s.inverse. Okay, so go to the cell where you want to calculate the z alpha over 2, put equal to, and then norms dot s dot inverse here. Return the inverse of standard normal cumulative. Okay, so double click and you need to put the probability. So just click at the alpha value and then enter. Okay, in this case it should be plus minus. So for two-tailed test, norm alpha over 2. So this one just now is finding the third. Okay, this one is norm dot inverse 1 minus. I forgot 1 minus AJ alpha over 2, so that it will be plus, it will be positive. 1 minus AJ over 2. Okay, 1 minus C63 over 2. Okay, you get 1.96 as what you got in your textbook. So class, remember, for two-tailed test, it will be 1 minus 6, the alpha value divided by 2. Okay, now once you have got that, okay, you have to find the E. Now the E will be, before you can count the E, is either, if you want to simplify, should be simplified this way. So E should be the multiplication of Z alpha over 2 with the square root of P hat multiplied by Q hat divided by N. So what should I do here? So I delete the X bar and okay. This is how Excel is a bit tedious if you, so let's say E is here. And how I calculate E, go back to your, where's the proportion? Yeah, this one. Z alpha over 2 multiplied with the square root of P hat multiplied with Q hat divided by N. Okay, so we are doing that. So at the beginning, it will be a bit messy because I need to explain one by one. Okay, let's begin. We have the Z alpha over 2 multiply. So multiply should be star. And then it should be square root SQRT. Double click SQRT. Then automatically it will give you open bracket. And we know that we have to multiply P hat Q hat. So the P hat is this one. So it's either you use P hat 0.4 is just to make things simple. Multiply with 0.6, that will be the Q. And it should be divided by the N. 1,500. Now, the one that you should make sure correct is the bracket. Now, I don't want the bracket to give me wrong answer. So all these things should be in one bracket because it is in one operation. So this one should be solved. Once it is being solved, then only multiply with 0, the Z alpha over 2. Okay, so enter. Hopefully it is correct. Now, see, if you don't put the bracket correctly, it will give you some comment. So double check, it should be square root and should be another bracket here. Okay, so you will get, but what is wrong over there? I think the multiplication. Now, double check. It should be the P hat. It should be P hat minus the E. So P hat should be 0.4 minus the E is C66. Oh, terbalik 62 minus 66. Just correct that way. Enter. Okay. And the same goes to the last one. It should be E plus 0.4. Okay. And it will get 0.42. Exactly the same as what you have in your textbook. So I think once you have got this correct with you, later you can use this easily. Okay, you just change the information n x p hat alpha, and automatically you can get the answer. So let's say we do exercise 3.2. Okay,
Teacher,
is there any question? Yeah.
can you go back to E?
E. Okay, E. This
Yes.
one,
Yes.
Okay. E is the one that we need to multiply using Z alpha over 2 multiply with the square root of P hat Q hat over N. So these are the component for E. So what did I do? I multiply this one is the Z alpha over 2, the blue one. Multiply with the square root of these things that I want just now. Square root of this. So the square root of this, since it involves multiplication, division, so put bracket correctly. So that's why double check. Okay. The first number, okay, multiply because this square root involve all things afterward. So put as in one bracket. So that's why I put bracket here, close bracket here. And the one inside the square root is the P hat, that will be 0.4. I automatically take the value, so it will be easy for me. So 0.4 multiply with Q hat is 1 minus 0.4 is 0.6 divided by the sample size value. That will be 660. This one. Okay. So enter, you will get the E, the margin of error. So that margin of error is the one that is here. Okay.
Okay,
Now
teacher,
be
thank you.
careful. Yeah. Okay. So be careful. If you wish to use this again and again, so what you can do, let's say I just move here. I do it using all the cell value. So equal to, I have the Z multiply with the square root. Double click square root. I take it should be P hat Q hat. So P, before that I should let's say I'll just take that will be P hat multiply again with Q hat. Let's say I'll just put here Q hat. Okay, and divided by the sample size. Now I have to put bracket so that my Excel can calculate it correctly. So here I have to put another bracket that will be for these two value. Hopefully it's correct. 1, opening bracket 1, 2, 3. Closing bracket 1, 2, 3. Let's see, is it correct or not? Now why 0? Because I didn't put my Q hat here. So I put Q hat here. It should be 0.6. Okay, similar answer, right? So to be easy, put n, x, p hat, alpha, q hat, and then z alpha over 2, and then your margin of error, then your calculation of your lower CI and upper CI. Okay, so this is my first using all the cell value. So look at the cell, and the other one is just putting all the value that I have for P and Q, and the rest is using the cell value. Let's say we copy this. Let's say I'm using my cell value. I delete this because what it changed. It should be this one. Enter, and this one should be move the cell where it should belongs. Okay. Then I copy again. I want to do the exercise C. Copy and paste. Let's say we repeat for exercise 3.2.
Madam, boleh tak ulang balik kat CI lower and CI apa?
Boleh,
Lepas.
boleh. Can I repeat at the exercise 3.2? Is it okay? I repeat again here. Ataupun, okay. For lower CI, we are calculating this value. The value, where is my example? Lama For CI, I want to calculate the value at here. Lower CI, and this is upper CI. Lower CI means that proportion minus the E. Upper CI, proportion plus the E. Right. So, we have got our E, we have got our P hat. So, it should be P hat, right? Remember, you should use your P hat for the proportion CI calculation. So, let's say I put in yellow. So this one is the one that you should use. So here, how I can get the lower CI? I calculate again in the next cell. So equal to P hat minus the E. So that I can get the lower CI. Enter. The upper CI, it should be P hat plus. So click plus E. Enter. So you get the upper CI. As simple as that. Okay?
Okay, thank you, madam.
Okay, thank you.
Madam,
Yeah.
yang untuk Z alpha bagi 2 tu, using Z distribution macam mana nak buat?
Macam mana?
Z alpha bagi 2 tu, kan
Okay.
1.95 tu, saya tak faham kat itu.
Okay. This is the same as what you got in table. If you go to table, go for alpha over 2 is 0.025, right? It will give you 1.96. But using Z distribution, we know that we should use this function. Norm S dot inverse. Why not norm dot inverse? And we are using 1 minus. 1 minus of what? 1 minus of C63. C63 is the alpha value. So just put accordingly. So let's say I do it again. So I have my alpha here because for Z distribution, for proportion, just use the alpha value. So now I go to equal to. So just remember which function that you should use. So norms dot s dot inverse. Double click. Okay, and it should give you should use the probability, but since we are using the inverse and we need to find the tail, not the middle value, so that's why we use 1 minus the 0.05 divided by 2. It become 1 minus 0.025. Okay, so enter. This is your Z alpha over 2. The same as what you found in your let's say, let me open the where is the table? Let me find the table. Table. Where's my lecture notes? Lecture. Table. Okay. Be patient. I think I'm very slow in explaining to you. So let us find the Z distribution or the normal distribution. Okay. Why 1 minus? Because we want to find for the alpha over 2. And for that one, we are going to use the right tail, this one, right? So we want to have for 0.0, the given alpha is 0.05. And since we need to find the low and the two tail, so we divide by 2, 0.05 becomes 0.025. So 0.025, 0.025. So in this case, the approximation is being used in this particular case. So you got directly 1.96. But using your Excel, you also get 1.96 for the approximation. Okay, is it clear, class? Especially the one who asked me just now.
Clear medium. Cuma tak tahu nak pakai function tu kan.
It's okay. Now, just remember, you are going to use this Z alpha over 2, this formula, you in your hypothesis testing, because you need to find the Z alpha over 2 as well, right? So it's actually the same as here. You can use the Z alpha over 2 here for your Z alpha over 2, but since the course coordinator has already prepared this way, so I follow. Okay, just remember, finding the CI for mean, you have this. Finding the CI for proportion, simply just use this. Okay, so just remember, because since you can use your Excel during your assessment, then please have your notes readily this way, so you can refer to it easily. But as for your final exam, you are not going to use the Excel, but we are going to give you everything. But as I mentioned before, you need to know how to interpret. Okay, you need to know how to interpret, because everything will be given, the p-value, everything are given to you. Okay, so it's just how you can extract the information and use that information in answering your questions. Okay, so this is how we train you as an engineer, not solely on how to calculate. And you have to remember, because you have all the tools and you can use the tools easily anywhere, everywhere. Okay, so for this proportion, let us continue for exercise 3.2. Okay, so exercise 3.2. Now, since we have got our the first what we call template, so we can use our template to calculate the next question. So the next question for exercise 3.2, let's say we solve for question number 2. Okay, page 96. Page 96. Now, what was the question? Hassan and Hizamiani wedding ceremony will soon be held at KLCC Convention Center. A survey is carried out to estimate the proportion of people who will attend the ceremony based on a sample of 250. Okay, I have a sample of 250. Okay, then 180 return the cards. That 180 is the X that is returning the card, because we are calculating how many of them are agreed to come to the ceremony. So your X is the one who wish to attend. So it will be 180 for your X. So automatically you get your P hat over here. So if you want to have your Q hat automatically calculated for you, you can just use erase this, use formula 1 minus your P hat. Automatically you get your Q hat. Now, what about your Z alpha? Your Z alpha, construct a 90%. So you are talking about 90%, your alpha is 0.10. So automatically, I go to the wrong one. How come? Okay, never mind lah. I'll just change this exercise 3.2. This is exercise. Never mind, I just undo. Saya sayang pula nak buat. Undo. I just undo. And is it correct? Undo. Okay. Okay, I'll just do it here. Your sample size is 250. Your X is 180. Your alpha is 0.10. And then your P hat is automatically calculated for you. Just your Q hat, you use your formula equal to 1 minus your P hat. Okay, now, so you got your answer automatically calculated for you. Right? Easy, right? Class? Are you all okay? Hello?
Ya, madam.
Sekejap, madam dengar.
Okay, why don't you try? Once you have finished, I want to move to CI for 2 population. I don't think I can cover the hypothesis testing. I don't want to mix up your mind, okay? I just want you to understand how to use this formula to calculate your CI using your Excel. I can hear something. Is there anything? Finish. Okay, finish. Okay, thank you. Okay, can we move to 2 population for confident interval? Okay, so you once what was that?
Boleh, madam, boleh.
Boleh, madam.
Okay.
Good.
Okay. Thank you. So now you have already know how to use this function for the first column. Okay, I put it in yellow, and then we haven't gone through this number 2. Okay, and we have gone through how to use this particular um, formula to find the Z alpha over 2 for 2 tail. Okay, now we are going to use this again for the hypothesis testing. Now, let us move to 2 population. Okay, so I hope once you have understood how to use 1 population, we just extend into 2 population. Okay, for the learning outcome, you can look on your own, and then for the concept idea, okay, you can again refresh whatever the things that we have covered before. And then this in yellow, explore concept of CI and HT, is actually an additional of the explanation that you have in theory in your textbook. Okay, I think this one I may not be good for me to explain using online, because I think it would be best if I explain it to you live, face to face. But the idea was, remember last time when we said we do resampling. When we do resampling here, this one, we have 1 population, and then we want to resample again and again. In this case, I take 100 sample. I repeat 100 sample from 1 population. And from this sample that we have, sample 1 until sample 100, we can estimate or we can calculate our X bar 1, X bar 2 until X bar 100. And if we plot this, if they are normally distributed, you can see all these sample 1 have got its own distribution. Small distribution that reflect the sample. But in overall, if I plot the overall sample, it will become this particular big normal distribution. And this is what we call population distribution. And the rest is the sample distribution. From this, okay, from this, how should I? Okay, from this, you can repeat that concept using a real value. That's why you have now, class, you have sample 1, sample 2 until 100 sample. And For each 100 sample, how many sample size, class, do you have here? How many, class?
30.
30. Yeah, you have
30 madam.
you have 30 observation for each sample. Okay, so from this they extend the knowledge and the understanding into the confidence interval as well as the box plot, just to show you how you can relate from chapter 1 until chapter 3 and how this came into your understanding. Okay, so that's why if you go further to the right, okay, you can have the explanation and everything. Okay, but as for now, I don't want to go into detail for that one because I'm afraid you might be confused. Okay, so for one population here, again, the intention for our course coordinator is just to show you in real how the data that we deal with in chapter 1. So I believe we have gone through this data in chapter 1 last time, and we come up with tables, we come up with bar charts and everything. So we extend how this data can actually being used in order to find the confidence interval, in order to perform the hypothesis testing and everything. Okay, so in this case, class, inference for single population, by using this data, okay, you can see in detail here. Okay, but now because we are talking about one population, we are considering beginner as one population, or you can choose advanced as one population. So just choose one only. We don't do both. Okay, choose either one as your single population that you wish to make inference for. So the next column, okay, is where you can repeat again in order to come up with your descriptive statistic. I hope by now you don't forget on how to come up with this. Can someone remember what is the function that we can use to come up with this particular result? Can someone please answer? What is the function?
Descriptive function from data analysis.
What was that? Yeah, I know from data analysis. Specifically,
Descriptive.
what is the function that you use for that? Yes, descriptive statistics. So class, remember, sometimes maybe during your quiz later, you don't have to calculate, but you can come up with your calculation based on your data. How to do? Let's say I want to generate my descriptive statistic for my beginner of my real data. Okay, we have the beginner and the advanced. So let's say I am dealing with this particular column only. So I have two population. So I need to come up with the descriptive statistic of one of them. Let's say I'll just choose the beginner. Okay, how? Go to data analysis. Go to data. What is my data analysis?
Home, doctor.
Home?
Yeah.
No. Why suddenly no data analysis in my laptop? Let me check. Page,
Tak data, madam.
formula, data. I know, where is in the data, but the icon is not
Oh,
there.
hilang tu.
Let me, okay. Let me put the ribbon so that, see, my data is missing. My data
Home,
analysis.
doctor.
Home, no, there is no
Is
at
it
home.
analyze data?
Why suddenly is
This
this
not.
analyze?
No.
No, it should be under data. If you go, okay, go under data, it should be at this side, data analysis. Okay, let me do it this way. I just save. Okay, I just save and then I close and I go back again so that hopefully it will be there. Okay, so Check again. Excel PNP lecture. Okay, hold on. It's a bit heavy. Okay. Data. See? Okay, got my data analysis again. Sometimes this is how we deal with computer. So let's say we want to generate this. Just go to data analysis. So you don't have to calculate everything again. So it will calculate for you everything. Descriptive statistic. Now we have descriptive statistic. Okay. So the things that we have covered before, let's say I just take the advanced. Okay. The column, it should be in column, label in the first row selected, yes. And then I want my output to be, let's say somewhere over here. And then it should be summary statistics, 95, okay. Then okay. So everything will be given this way to you. So you don't have to calculate and everything. So in fact, the standard error, the standard deviation and everything is there. So from this, maybe later you will have to start from the beginning. I don't know. Okay. So let's say this is how I have calculated for you. Assuming that we are calculating for beginner only. Or if you wish to calculate for advanced only, then this is how we can come up with this confidence interval and so on and so forth. It's just the same as what we have done just now. So I don't want to repeat again. So I think the simplest one is following the one that we have done earlier. Let's say we are dealing with two population now. Okay, for two population. And I wish to use the textbook example because it should be easier for you. Let's say I have done something here, but let's say I want to use my example 3.10. Let's say, let me check again. 3.10. Yep, hypothesis testing. Okay. Now, let's say, okay, for two population. Assuming, okay, let's say we don't look at the example in your textbook. Okay, I hope I can finish at most at 10:15. If you are all okay, then I will just continue until two population for CI. Okay, let's say we generate this using your Excel, and we have all this information. What the most important thing is we want to find the CI for the mean. The mean. So mean for beginner and mean for advanced. Okay. Okay, now because the setting is already into population, so we use this. Okay, before we can use the example 3.10. Okay, now I put my mean for beginners and everything. Let's say beginner is 16, advanced is 9.83. I set for two decimal point. Okay, and automatically I generate my difference. Okay, the difference, because for two population we are counting the difference. Okay, counting the difference. That's why here beginner minus advanced. That's why I have equal to beginner minus advanced. Enter. I got this value. This is the difference for beginner minus advanced. If you want to be more clear, you can put difference beginner minus advanced, so that you can more clear. So you can add in your Excel sheet. Okay, that will be the first part. The second part, okay, we know that for two population, for mean, we have these three cases. Okay, so you have to look at your cases where you are given the information, which are the cases applied. So let's say we are using this particular example in order to find the CI for the difference between the beginner and advanced. Okay, now Let's say in this case, we are using 95% confident level. So for 95% confident level, we have 0.05 significant level or our alpha. So this will be our alpha. Okay, so it will be much clearer. Okay, now, then I have my alpha. I have to find the critical value. So the critical value is almost the same as what we repeat in proportion just now. Norm dot S dot inverse 1 minus the tail divided by 2. Okay, we got 1.96. You have this in your Excel sheet. Okay, just follow me with the instruction. Now, what is standard error? Okay, standard error is actually you can see from here. Okay, standard error of the formula is the standard deviation divided by the square root of n. Okay, if you wish to calculate the standard error, it will be, but in your case, we don't use the standard error. If you wish to calculate, it's just the standard deviation. In this case, is the, yep, it is calculated over here. Okay, you can use the standard, but in this case, I don't think we need to calculate the standard error. We just need to find the margin of error. So the margin of error is what? This one. What is this? Since we are dealing with two population, okay? Now, if I go back to your slide for two population, for the CI of the mean, okay? For the CI of the mean, okay? For the CI of the mean, the standard error, the margin of error is this, can be this one if sigma is known. If sigma is unknown and the covariance, the variance, the standard deviation is not equal, then this become the calculation and followed with the cases that we have. So that's why, class, for mean, it will be a bit tedious because you have to check which condition applied to your problem. So let's say we go back to our Excel. Okay, so in this case, let's say we assume then the from this case we have the beginner. So here is the beginner. Let's say I put the beginner so that it will be clear. And this one is for advanced. Okay. Are you all still okay, class? I'm afraid you are exhausted already.
Yes, okay,
Huh?
okay.
Okay, eh? Okay. Now, before we go to the example, we just take this as so that you can understand what are in this particular sheet. So we just copy all the information from this descriptive statistic. That's why here I just call where the location of the sample 1, which is here, and then call for the location of sample 2, which is from here, and then call the x bar, the mean, where I just take from here, and the second mean from here, and standard deviation for each. Okay, so we have the standard deviation from the start here. Okay, so I just put it into 2 decimal points, so it will be easy. So if you need to use 4 decimal point and then set for 4 decimal point, how? Go to the cell, right click. So since this is referring to the cell, so I have to go to the cell where it is from. So here, let's say for the standard deviation, okay, if you want to set for 4, okay, go to format cell, number, just put 4, and then it will be set for you for 4 decimal point. So be sure of what decimal point. If you are not being asked for 4 decimal point, it's up to you to use 2, 3. It's up to you. Okay. Now, once you have got this, you have N1, N2, X bar 1, X bar 2. We know that we have got our difference. Now, how to calculate the margin of error? So look at the cases where we have. So in this case, let's say we assume since we are dealing with small sample size, okay, and sigma is not known. This one is alpha. I forgot wrong. Alpha. So assuming that this is a small sample size, okay, and then in this case we are calculating the margin of error. So the margin of error, okay, margin of error. So V is referring to what just now? V42. V42. Where is V42? V42. Okay. Okay. So this one is I almost forget. So V42 is your Z alpha over 2. Now we are calculating for margin of error. So we take out Z alpha over 2. In this case, is it Z alpha over 2? Let me check. Yeah, I use Z alpha over 2. It should be T, right, class? It should be T, right, class? Let me go to T distribution for two-tailed test. It should be T inverse. Okay? It should be T inverse. Let me check. Copy paste this. Control C. Okay, I put it here. It should be T inverse. Let me correct this. It should be T inverse. T dot INV, and it should be the probability. That will be your alpha. And degree of freedom. So your degree of freedom, so in this case, let's say I just put N first, put 3. I don't know. We have to check. Okay, let's say we are assuming this as case. Let's say we just use case N less than 30, so unequal. Let's say we put it as unequal since standard deviation is almost the same. So let's say this is where the case 3. Case 3 and sigma 1. Let's say sigma 1. Sigma 1 is equal to sigma 2. We assume, because we don't know the condition. Let's say we assume sigma 1 is equal to sigma 2. Okay, so this one should be used for the margin of error calculation. Okay, for this, we are going to use the T distribution. For the T distribution, let us check how we can find the T distribution for less than 30, we assume equal. Equal is this one, right? So it should be N1 plus N2 minus 2. So we add the 2 and minus 2. Okay? This one is for not equal. This one is for equal. So go back to your Excel. So we know then it should be what? This one plus this one minus 2. Let's say I put it minus 2. Okay, what happened here? Is there anything wrong? Let's say I close the bracket here. Kat kunci. The bracket is not correct. Inverse 1, 2, 1, B. Or, let's calculate lah. 12 plus 12 minus 2. 24 minus 2 is 22. Okay, what's wrong here? Let us check again. It should be plus minus should be positive Excel function. For two-tailed test, okay, 1 minus AJ. What is AJ? AJ is the degree of freedom is 10. Okay, so we go for our calculation. Okay, so it should be 1 minus. Okay, 1 minus. Okay, and you get your value of your T distribution. Okay, once you have got your T distribution, we want to find the margin of error. So this is the formula. So this formula reflect this one. Okay, so let's say n minus 1. In this case, I have to redo again because we are using the this formula. It should be n minus 1 multiplied with s1 squared and everything. Okay, so let's say we recorrect this. It should be let me just use my textbook to refer so that it will be easy. So it should be square root of this one is a bit complicated because you have to calculate the pool SP and everything. Let's say we assume this. In this case, we assume sigma 1 is not equal to sigma 2. Okay, not equal to sigma 2, just to simplify the calculation. Okay, I will share with you this slide, this Excel sheet again. Okay, not equal to means that we are using formula of this one. Okay, and we should correct the degree of freedom. That will be the minimum of either one. It should be n minus 1. It should be 11 then. Okay, so it should be here. It should be 11, not 22. Okay, so you have your T alpha over 2 and then multiply with D using the formula. Okay, and then now in order to calculate the lower limit, so we are using the difference. So let's say I copy the difference here, Control C, and the difference is here. Let's say I copy the value, Control C. Okay, now I want to calculate the lower limit using the difference. Okay, the difference between the beginner and advanced. Okay, so I have the difference. So let's say I redo again here. It will be equal to the difference minus the margin of error. You will get negative. And then for this one, it should be the difference plus the margin of error. Okay, so you will have this. Okay, so the confident interval, 95% confident interval for this is between negative 1.92 until 14.25. Let's say we do for example 310. Okay, we have another few minutes. Let's say we use example 310. Okay, So example 310 would be a bit easier for you because everything we have done in the class. Now, example 310, you have to, let's say I just, okay. Okay, now, two machine are used to fill. Okay, N1, blah, blah, blah. N1 is 14. N2 is 12. And then X bar 1 is equal to 30.5. And then X bar 2 equal to 29.4. Standard deviation, now, look at the information. The standard deviation of fill volume are known to be sigma 1. So now you are talking about sigma. So change. So that you are clear, sigma. Sigma means that you are not going to use the tedious formula. Okay, then you have sigma 2. Okay, sigma 1 is equal to 0.005. And sigma 2 is equal to 0.025. Okay, now, in this case, we have our X bar 1 and X bar 2. Let's say we don't have to use this one, so delete. Okay, no fill, no nothing. So the difference is based on this one, yeah? So the difference it will be X bar 1 minus X bar 2. X bar 1 minus X bar 2. Enter. So you are referring to this difference. Now, the confidence level. Construct and interpret 90% confidence. So you are talking about 90%. So then you have 0.10. And then in this case, now we are using Z distribution. Z distribution or normal distribution. Okay, using Z. Standard normal. Okay, so 1.6449 is the same as what you have in your textbook class, right? Page 110. Now, the margin of error. For this margin of error, we know that we are referring to this particular formula, the simplest one. Okay, sigma 1 squared divided by n1, sigma 2 squared divided by n2 square root. So let us check, is it correct? So it should be sigma z alpha over 2 multiply with square root of sigma squared. Okay, sigma, that will be 0.01. The red one here is the red one here, squared, divided by 63. Why 63? Correct? Plus, in bracket, okay, sigma 2 squared divided by the sample size. Okay, so I hope this is correct. So if you look at your okay, so you will get is there anything wrong? Let us check here. It should be okay. Where is the one that is missing? See, the cell is looking at here. The cell should be, you drag down to the correct difference. Okay, it should be the difference minus the margin of error. The difference is U57 minus V65. Correct. So you get 1.1. So another one is, see? Okay. So the difference plus the margin of error. Click. Is there anything wrong? 1.09, 1.11. Let us use 4 decimal point just to be sure. Huh? Let's say X bar. Do you have any suggestion why The answer is approaching the same value, class. The margin of error 1.644. Let's say we use until 4 decimal point. 1.4. Class, are you all with me, class?
Yes, madam.
Yes, Doctor.
Macam dah tak semangat je. Sorry ya. Macam dah exhausted semua. I set to 4 decimal point. Hopefully it will give the same value. 1.6449. Is it the wrong one? Is from the difference is 1. What is the difference? Can you calculate, class? 30.5 minus 30.5 minus 29.4. This is the one which is wrong. 30.5 minus 29.4. Correct?
Yes.
1.1, correct? But in your textbook, you get 1.09. 1.09. Okay, 1.09 minus the margin of error. The margin of error in your textbook is 1.6449. I want to check the value. Is it the same? Multiply with 0.0073. Wrong. So this one is wrong. What is wrong with it? Let me check. V61 multiply with square root 0.01 squared. No one correct me. Sigma 1 is...
Doctor, because it's in 2 decimal places. That's why it's 0.01.
It should be 0.05, right?
0.005.
Yeah, 0.005. And then the other one is... Oh, okay. Just put it as 3 decimal point then. Let's put 4. Okay. And here should be 3 decimal. See, class, how this decimal point can give you a different answer. Okay. So now, okay, 0.0, but now it's still wrong. Sigma, okay, V61 multiply with square root of 0.00 squared divided by Y63 plus AA squared divided by... Okay, I think I should use this way. Is it because of this bracket? This bracket is for this one. This bracket is for this one. Is it correct? Enter. No, still the same. Square root. This one. I know. This one should be this one. 1, 2, 3, 4. 1, 2, 3, 4. See? Okay, now because of the bracket, so I guess you have to use the correct template to help you out with the calculation. So I believe now this is the correct template and with the correct bracket. So hopefully everything is correct. So now since we have the correct answer and we can use this as our template to do the calculation for two population. But since for the mean is the tedious one, so whether you like it or not, so you have to go to the cases where you have to identify which of the case apply to your calculation. Now, do you want to go for the proportion for the mean? I think it should be clear. For the proportion, let's see whether I have written down for the proportion. Now for the hypothesis testing, I'll just leave it on Monday. Okay. For the proportion, let's say for the proportion. Okay, example 311. Okay, sorry class, I think I just want to show you for the proportion. So it should be, okay, for the proportion, I think I want to copy the one that we just do. So it would be easier for the proportion. Okay, Control C, to population. So I put it here. Okay, for this one is for proportion. I will share with you this template later. So let's say for proportion, we are talking about example 3.11. So example last before we dismiss example 3.11. Okay. Let's say we put it this way. Okay. Okay. Let's say I have sample 1. Let's say I put it population 1 and population 2. Okay. Now, okay. For 3.11, we have 250 car driver. So, this is one car driver, motorist. Okay, so 250. And then 220 favored, 220. Motorists, we have 200 motorists. And the X for motorists is 180. Okay, so this one is equal to this one divided by this one. Just copy. Okay, this one, calculate using this one. Okay, alpha, let's say we rearrange. We put Q hat first, so it will be much easier. So Q hat is equal to 1 minus the P hat. This one is equal to 1 minus the Q hat. Okay, and this alpha, we are using the same alpha. So alpha in this case is 95%. That will be 0.05. Okay, now since we are dealing with Z, proportion is the most easy one. So we don't have to worry because we are using the Z distribution. So for Z distribution, okay, it will be, there is something that we need to correct this one. Norm Z alpha over 2. So this one is 1 minus. The place is wrong. Okay. Enter. So you have 1.96, correct, right? So this is your using Z distribution. So for your margin of error, now, before that, we need to find the difference. Just put one more column, one more row for difference. Or you can put it as P hat, P hat car minus P hat motorist. Just put motor here. So here it should be equal to P hat minus motorist P hat. So you get negative 0.02. Okay. So that will be your difference. And then this is your Z, correct? Now we check the E. What is wrong with the E? See, U81 is your Z alpha. U81. Z alpha multiply with square root of U. It should be what? Now the calculation, we should correct them because the calculation is following the proportion. Where is the proportion just now? Yeah, this one. Square root Q hat P hat 1 and P hat Q hat 2. So using this particular calculation, we correct them. E, okay, it should be square root of P hat Q hat. So P hat multiply with Q hat. The Q hat should be this one divided by the, okay, good for the first one. And then for the second term, plus bracket. So the bracket should be P hat for motorist multiply with Q hat for motorist divided by this sample size. Okay. And then this one should be close with, let me check the number of bracket. 1, 2, 3, 4. 1, 2, 3, 4, 5. Missing another one. Please correct. Let me check again. The square root. Class, be patient. Just my last example for the proportion. This is the tedious part about this one. I want to show you because I want to show you how tedious it is when it comes to the Excel function. You have to make sure everything is correct. So V1 P hat 1 P hat 1 multiplied with Q hat 1 divided by the standard divided by the sample size. I think the bracket is too much here. Let's say this one is this one and this one. Bracket and bracket. Okay. Plus. Okay, I want to erase first so that it will be easy for me. Hold on. So the first bracket is for the multiplication of the P and Q hat for sample 1. And it should be divided by the sample size. Okay. And the same goes to this one. P hat, Q hat for sample 2 divided by, so this one should be another bracket. Okay, bracket, 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 bracket. So there should be another bracket here for the whole 2 population. So let us check. Okay, yes. Okay, so here it should be square root over here and here. What is wrong with it? E 1, 2, 3, 4. 5, 6. 1, 2, 3, 4, 5, 6. Betul? Square root. So is it? No need this one. Okay. Okay, now check. It might be correct. So this one should be lower, should be P, the difference minus the E. Somehow it was correct just now. I did not check this particular formula. It should be plus U 80 according to the plus the E. Finally. Okay, class. So we have got our calculation correct. So this template should be okay for you to use for the calculation of the confidence interval for two population involving the proportion of two population. So do you want to stop here or you want to try the exercise for proportion difference? Class, do you want to stop here? Class? Are you all here? Or are you all surrender already?
Surrender.
Yes, madam.
It's better to stop, Doctor.
Okay, so do you want me to stop here or try one question so that we can check with the answer? Last point, last, yeah? We try last, huh?
Okay.
Okay, we copy. And then we do for exercise. We do for exercise. Exercise 3-7. Now we just put everything together. We are talking about the damp, the one that you have done, damp and dry. Dry. Okay. The damp involve 100 electronic connection, 100. And the dry, 150. Okay. The X for damp is 20. And the X for dry, 10. Okay, so you got the P hat. So let's say we set for, let's say for, in this one is 2 decimal points. So we set for 2 decimal point, go to number 2. And then the rest also we put 2 decimal point. Okay. So now we have P hat, Q hat, correct. So we have alpha is how many percent? 90%. So 90% is 0.10. Okay, 0.10 P hat. Let us check. So damp minus dry. Okay, the Z. Okay, the Z using 0.1 is 1.64. So the margin of error is 0.07. So the answer is 0.06 until 0.21. Directly you get the answer correct. So it's just that you have to interpret. So class, for your quiz, you have to use, you can use your Excel or you can use manual calculation and make sure all the required answer you can write down on your paper, because we are going to submit you have to submit your answer on paper. Okay, done. So I will share with you the template afterwards, okay, so that you can try the tutorial questions while waiting for our quiz one on Thursday. So you can try the questions under tutorial. So you can just use your Excel to help you out with the calculation.